Hey there. This is just a recap of the activity we did in class, and we're just going to kind of cut to the chase and give away the fun result. We were looking at graphs of composite functions, and let's talk about what a composite function is. Composite function really is just a way of combining functions together. Now specifically we're working with sine functions, and we're going to combine them through some sort of addition and multiplication. In other words, I'm going to take my sine function and I'm going to add some other function to it. Perhaps it's a quadratic function, and we'll just do the parent graph. We're just doing parent graphs today to keep life simple, but we're going to look at, well, what would a function like that look like if you had two different types of functions being added? Likewise, we're going to look at taking a sine function and multiplying it by another function, and what happens there. Now what we did in class was we went to Desmos and we just started playing with some functions and seeing what happened. And ta-da, here's what happened. We learned that, and in these, I have two examples here. I'm going to go ahead and use my sine function, and for both of these I'm going to be looking at what happens with an absolute value function. You know that an absolute value function is a V-shape, so you can see in my picture here I graphed the absolute value, which is the blue graph there. And then I graphed the equation of this composite function of taking the absolute value and adding it to sine. And what ends up happening when you add two functions together, and specifically the sine graph, our sine wave that we're used to seeing actually sits there and wraps around the function that you are adding. The reason it's doing that is because, remember, when you add something outside of the parentheses, it's really a vertical displacement. My graph, my sine graph, is going up by whatever the absolute value graph happens to be at that spot. At 0, the absolute value is 0, so my sine graph is still at 0 and it doesn't move up. But as the absolute value starts heading up, my nice sine wave that I had here has to also move up. And it looks like it wraps around that function. When you do multiplication, this is more like your A value. It's like your amplitude. And it tells you how far to stretch your graph up and down from the equilibrium. Well, because this is not a constant, this is a variable here, it's an absolute value function, the amount that I need to stretch my wave is going to vary. It's going to actually follow this absolute value, because as the x gets farther out here, it looks like I need to stretch it more because the absolute value is getting higher and higher. You can see that that makes my sine wave stretch higher and higher and higher, and it is typically symmetrical looking, and so the bottom half has that look as well. So let's summarize kind of what we need to know about composite functions. If we are ever adding some function to our sine function, and again, we're kind of specifically looking at sine functions today. If I'm going to add them, then the sine wave sort of wraps around the added function. When we are multiplying functions, it stretches to meet up with, or to touch, I'll say to touch the multiplied function. Let's try some other types. What happens, and we're going to focus first of all on adding functions. And I'm going to take my sine graph and I'm going to add the square root of x. The first thing you need to remember is, what does the square root of x look like? And it's like a sideways parabola. Actually, I'm going to do it like this. I'm going to do the square root functions together. If I'm going to add it, And if I'm actually going to graph this equation right here, what will happen is my sine graph will kind of start wrapping around that. Now, it totally depends on how much you zoom in or zoom out, how much of that wrapping you really can see. It really does sort of do that, but you don't always see it very nicely depending on what your window is. Now when I'm multiplying it, and see how I put the addition, I tend to put it on the back end like it's the vertical displacement. When I multiply, I put it on the front end like it's the amplitude, because that's how it's affecting the graph. This is going to take my sine graph that I normally start at 0, and it's going to start changing how much my amplitude goes. And so it would kind of follow that path, and then it's sort of symmetrical as well. So you can sort of see the bottom half of this parabola going down there. All right, now notice that the blue part is my official answer. The red part just helps me get it graphed. The blue part is my graph. All right, let's try it with a parabola. We have an x squared. I'm going to graph the x squared. When I add, it tends to wrap around. You're going to look at it and it's going to kind of have this look where it wraps around that because it's shifting up in some places. When I'm multiplying, it's like the amplitude, and it tells me how high to stretch the graph, and so it kind of follows. This parabola comes up and touches. It does the same thing on this side. All right, and obviously you can tell we don't get too worked up with exact points or anything like that. Just kind of get the gist of it and understand what would happen. Last one. We have a 2 to the x. That's exponential growth. Exponential growth looks like this. If I'm going to add the sine function to that, it's going to make it kind of wrap around it. And if I'm going to multiply it, it makes it stretch. And so forth. Down here, I'm not going to see as much going on. All right, so that's the gist of what we did in class on 4.6.